Major meteorological agencies spend a massive amount of resources tracking the Pacific Ocean for signs of El Niño. But while the world watches the Pacific, another massive climate driver is waking up in the Indian Ocean, dictating weather patterns for over 2 billion people. Imagine reading the news and seeing that Western Indonesia is suffering through a severe, months-long drought. Then, a few months later, rural villages in Kenya are suddenly submerged in muddy floodwaters. To the people living through them, these events feel like isolated strokes of very bad luck. They are part of a single, unified system. Meteorologists track these geographically distant disasters and map them back to the exact same atmospheric trigger. These extreme weather events are driven by a phenomenon called the Indian Ocean Dipole, or IOD. You can think of the IOD as a giant shifting seesaw of ocean temperatures, balancing between East Africa on one side and Indonesia and Australia on the other. When that seesaw tilts, it redirects atmospheric moisture across the entire Indian Ocean basin. Tracking which way this system leans gives us the ability to predict regional crises 3 to 6 months before they hit land. Under normal baseline conditions, trade winds blowing west to east push warm surface water toward Indonesia, forming rain clouds there while keeping East Africa dry. Periodically, those winds weaken. The warm water sloshes backward toward the African coast, creating a positive phase IOD. The rising moist air follows the heat. The coast of East Africa and the Middle East receives massive unseasonal rainfall, triggering flash floods and landslides. At the exact same time, on the opposite side of the ocean, cold water rises to the surface near Indonesia. This cold water chokes off the moisture supply to the atmosphere. Rain stops falling across Southeast Asia and Australia, plunging the region into severe drought. The vegetation dries out and becomes highly flammable, acting as the primary fuel for the catastrophic 2019 and 2020 Black Summer bushfires in Australia. These fires burned over 24 million hectares and were driven directly by one of the strongest positive IOD events on record. A spike in ocean temperatures off the coast of Somalia dictated the ignition conditions for megafires 6,000 miles away in Sydney. The system can also swing to the opposite extreme. In a negative phase IOD, trade winds strengthen, forcing that massive pool of warm water toward the coasts of Indonesia and Australia. All that concentrated warm water fuels intense cloud formation. Australia and Southeast Asia get hammered with well above average rainfall, widespread river flooding, and tropical cyclones. With moisture pulled entirely east, East Africa is left with cold water upwelling. The rain shuts off, leaving the region suffering prolonged, crop-killing agricultural droughts. This image maps global sea surface temperatures, showing a massive red heat anomaly stretching across the equatorial Pacific Ocean. This is El Niño. When El Niño alters atmospheric pressure, it frequently forces the Indian Ocean Dipole into a positive phase. Meteorologists call this climate coupling. El Niño naturally suppresses rainfall over northern Australia and Indonesia from the east. A positive IOD cuts off their moisture from the west. The two massive ocean systems act like two arsonists pouring gasoline on the same house. We can see the historical impact of this coupling. These 4 satellite images track the Indonesian forest fires from 1997, when both systems locked in at the same time. The resulting smoke spread for more than 3,000 kilometers, choking 6 different countries. When the Pacific and Indian Oceans synchronize, these localized dry spells combine to form a massive multi-continental drought. The fallout from the IOD extends heavily into public health. In 2006, when a combined climate event caused the worst flooding in 50 years across the Horn of Africa, the stagnant floodwaters triggered immediate, deadly outbreaks of cholera, malaria, and Rift Valley fever. In the oceans, the rapid temperature shifts trigger massive red tides. These toxic algae blooms collapse local marine ecosystems, wiping out fish populations and disrupting food supplies for millions of people across the Indian Ocean rim. We have an advantage. Recent breakthroughs in meteorological modeling allow scientists to accurately predict the swings of the IOD months before they make landfall. If predictive models point toward a positive phase, residents in dry zones like Australia and Southeast Asia have months to clear defensible space around their homes and stockpile N95 respiratory gear for the inevitable wildfire smoke. At the exact same time, communities in the incoming wet zones of East Africa know to begin mapping evacuation routes to high ground and establishing 72-hour clean water filtration setups before municipal systems are compromised. We cannot stop the oceans from shifting. By tracking the data and understanding the mechanics of the Indian Ocean Dipole, we gain the crucial time needed to prepare our communities and survive the flux.